Welcome to Module D, Lecture 7. In this lecture, we shall discuss about Bureau of Public Road Calibration Procedure, or what is commonly known as BPR calibration procedure for the friction factors. In the previous lecture, lecture 6, we discussed in details about singly constrained gravity model, why we call them singly constrained, mentioned that it could be production constraint or it could be attraction constraints. Then we said how stepwise we develop such models and apply them. Then took an example also to demonstrate how such kind of models can be applied to get the trip interchanges and also to get the trip interchanges which will match the row totals and the column totals. That means, which will match the productions and attractions both constraints. And as we used singly constrained gravity model, it automatically ensured matching of one end. We used production constraint model. So, the production end matched, but the attraction ends did not match automatically. So, we explained to you how externally we can do iteration and balancing, so that the attraction ends also match closely. That was explained in the previous lecture. But if you remember the example we took, we said someone has developed these friction factor values for you. We took an example, productions, attractions and also the travel time distribution, and then we gave a corresponding Fij values corresponding to the travel time, and we said somebody has developed this friction factor values or friction factor curve for you. Now, in this lecture, that is the point where we want to focus, how to develop these friction factor values or friction factor curve. That means, time versus Fij values. How to develop that? Somebody has to develop, then only one can apply. So, here we shall focus on that part, how to develop the friction factor values from the corresponding travel times. We shall follow a procedure what is known as BPR calibration technique, popularly known, and that following that BPR calibration technique, we shall explain how this can be applied to develop the Fij values. So, what we do, this BPR calibration procedure, it is the most widely used technique for calibrating the gravity model, and what we are essentially doing, we are actually using again here a singly constrained gravity model inside. So, you can see this equation, you are quite familiar with this equation by this time. Tij equal to Pi, a fraction of Pi will go to a particular zone j. How much fraction will go? Aj Fij divided by sum over Aj Fij, sum over all j, right. That is the fraction that will go to a particular destination j. So, this is the basic model that will be used inside even during the calibration. Let us take an example, and with this example we shall explain the steps, because if I explain only the steps without an example, it may be difficult for you to understand and connect all the steps. But so, I tried to take an example and then go stepwise with reference to this example, so that things become very clear to you. Let us consider a study area with 5 zones. The data is given here again, zone to zone adjustment factor initially we are assuming as 1, we are not using any zone to zone adjustment factor now. And let us say that zone 1, 2, 3, 4, 5, there are 5 zones, the productions are given, for example, 5000, 2500 in zone 2, 4000, zone 4 2500, zone 5 3000. Similarly, the attractions for all these 5 zones are also given, 4500, 3500, 4000, 3000 and 2000 respectively. Then the travel time matrix, I have adjusted the tables like this. So, after this production attractions come to the travel time between zones. So, how these are connected, different zones are connected, and what is the travel time for each pair of zone, right. So, if you want to go 1 to 2 15 minute, 1 to 3 25 minute, 1 to 4 20 minute. This is an example. So, I have taken the travel times in multiple of 5, but this is nothing like you cannot take other value, you can always take any value, right. In this example, I have just taken travel time values which are in multiple of 5 minutes. But as I said, any value, any range is fine. If you take a big city, if you say Calcutta, or if you take Mumbai, or any other city, the travel time will vary, maybe vary from 5-10 minutes to even 120 minutes, 2 hour, even more, right. It can happen. The peak hour, it may even take 2 hours, right. So, the travel time range could be quite big, but here it is just an example, because my sole purpose is to explain you clearly the steps, how we develop. So, I have taken an example which is relatively simple. So, my travel time values are there, right. So, you can see here what are the discrete travel time values 5, 10, 15, 20, 25, 30 up to 35. Okay. So, finally, for each of these travel time values, I need to find out the corresponding Fij value. That is what is my objective, that is what the calibration we want to do. I have assumed here some values. Let us say for 5 minutes it is 4. You know already that logically higher the values less of travel time, lesser should be the values for friction factor. So, that trend is maintained, right. But who told me 4? Nobody, it is just my assumption. Instead of 4, you could take 40 also, does not matter. Take any value, even if you suppose you have forgotten that the higher the value, lower will be the friction factor, higher the value of travel time, that lower will be the friction factor values. Even if you have forgotten, you have taken say reverse. Let us say 5 minute you have taken 0.08, and then 10 minute 0.011, and then finally 35 minute you take 4. You have taken just a reverse pattern, still does not matter. Finally, everything will be shifted up. That is what is the beauty of this calibration technique. Or even if take equal value, I do not know 5, 5, 5, 5, 5, all 5 minute, fall friction factors are 5 or friction factors are 10 or 1, anything you like you take, it does not matter, you assume any value you like. Okay. Then stepwise we can go and we can get the final curve. How we get it? So, the stepwise, if I have to say, the first step is the entire area may be divided into zones, and each zones may be represented by a centroid, the nodes representing the action of intersection between the links and the street system, right. So, these are all the basic things which anyhow you have to do if you are actually trying to calibrate a friction factor curve or friction factor values. Then, as I said, the travel times are known. How travel times are known? Again, it is a network. So, there will be multiple connection, multiple paths, right. So, you have to probably get the minimum travel time path or the shortest path you have to get, and those travel time you will put in the particular cell. Say for example, 3 to 4 if I go, if I want to go, then maybe 20-minute time, that is along the minimum path. So, I know this is the minimum travel time, right. These are the practical, I am saying practical aspects, because here I have given the time, right, but what these times values indicate? They are the actually zone to zone along the shortest path, that is what I want to mean. Now, as I said, you know what is the range of travel time or what are the discrete values in this case. You know that 5, 10, 15, 20, 25, 30 and 35 are the discrete values in this case. You have to make an assumption of the corresponding Fij value. I said clearly, take any value you like, take all equal value, no problem. Take higher value for lower travel time and lower value for higher travel time, which is logical, that is also fine. If you take just reverse, you take lower value for lower travel time and higher friction factor value for higher travel time, that is also fine, it does not matter. Assume something. Once you have done it, then the next step. What is the next step? The next step is basically I am going for the first iteration. What I will do first? I know the travel time, intrazonal and interzonal travel time from the given matrix. So, I shall actually take those values and then take the corresponding Fij value. For say example, 1 to 1 travel time is 5 minutes. So, that means my Fij value is 4. 1 to 2 15 minutes, that is why that means my Fij value is 0.44. So, I make a matrix of Fij from the known travel time. I now convert those travel time and get a matrix which is basically Fij matrix. Then assume travel time, with this assumed travel time factor relationship, we now go for application of a singly constrained gravity model with these friction factor values, which are assumed friction factor values for different travel time. Use a singly constrained model and go for the trip distribution. Okay. So, that is step 2. I have shown it here. The first table on the left, the green arrow shows how one table to another table to then 3 tables are shown. So, we start from the left top table, then go to the right top table, and then from that we get the finally the table which is shown in the bottom. So, the first one what we calculate, we know the AJ value, attractions of each zone 1, 2, 3, 4, 5, all these zones the attractions are known. So, attractions are given here, right. Zone 1 attraction 4500, zone 2 3500, zone 3 4000, zone 4 3000, zone 5 2000. And then we know also these Fij values. Take the zone 1 first. So, 1 to 1, 1 to 2, 1 to 3, 1 to 4, 1 to 5. So, all are AJ means attraction of zone 1, attraction of zone 2, second case, third cell attraction of zone 3, fourth cell attraction of zone 4, fifth cell attraction of zone 5. But then F11, F12, F13, F14, F15. How we get these F values? We know the travel time, and from that we have also calculated or formulated these friction factor tables. So, F11 is 4, F12 is 0.44, F13 is 0.16, F14 is 0.025 and F15 is 0.08. How we got these values? Again, to remind you, we got these values because we know the actual travel time, that is what is the given here, and we have assumed certain values of friction factor corresponding to various travel time. So, as per the given travel time and as per the assumed friction factor values, we know what are the Fij values for the specific pair of zones, and accordingly we can calculate this Aj Fij, right. So, for zone 1, zone 2, zone 3, zone 4 and zone 5 to all the destination zone 1, destination zone 2, destination zone 3, destination zone 4, destination zone 5. So, all these values you can calculate. Once you know these values, you can also calculate sum over Aj Fij, each row, just add the total, that will give you for all destination zone j what is the total. That means, in the first case 18,000 plus 1556 plus 640 plus 750 plus 163, that is the total sum over Aj Fij. Then each cell like that I can do it for 1, 2, 3, 4, 5, all cases for every zone I can calculate sum over Aj Fij. Then each cell divided by the sum of the total for this corresponding row. So, Aj Fij divided by sum over Aj Fij, those values are shown in the second table on the right corner, right top. Once you have done that, then for each origin zone, like zone 1, I know what is the value of Pi. How do I know that? That is again given. The production values are given, okay, right. Each zone the productions are given, for 1 5,000, 2 2,500, like that. So, let us say zone 1 5,000. So, 5,000 into 1 is 0.853. So, 5,000 into 0.853, that gives you 4264. 5,000 into 0.074, that gives you 368. 5,000 into 0.030, that gives you 1652, like that you get 178, and then you get the 3915 T15. All these values are known, and if you sum it up, you are seeing that you are getting 5,000. Again, no wonder, because you have used a production constraint gravity model. So, obviously, the row totals will match. Column total as usual did not match exactly, but we will not apply the balancing now at this stage, right. So, we go ahead with that. So, now if our assumed friction factor values are correct, I repeat, if our assumed friction factor values with respect to different travel times are correct, then this distribution grossly what we got should match with my observed distribution. Okay. How we compare these distributions? What we will do? We will calculate now the trip length frequencies. What does it matter? That means, we are not going to compare zone to zone values. We cannot do that, because what is our objective, why we are not doing it now? Tell me the answer, why we are doing it, not doing the cell to cell comparison now? Because our basic purpose at this stage is the calibration of friction factor, time vis-a-vis Fij value. That is what is our target. Are we able to properly calibrate that curve? Are we get really suitable values of Fij corresponding to every travel time value? So, what we will do? We will calculate trip length frequencies with respect to each travel time. That means, in the network we know that I have some 5-minute travel, I have some 10-minute travel, we have some 15-minute travel, 20-minute travel, 25-minute, 30-minute and 35 minutes in this example. So, with each of those travel time, how many total trips are being made as per my model estimates? They may be happening multiple pair. So, maybe 10 minutes may be not just one pair, but multiple pairs. If there are say 2 pairs where the trip distribution is happening with 10-minute travel, I will simply add those 2 values, because I want to get total number of trips with 5-minute, total number of trips with 10 minutes, total number of trips with 15 minutes and so on. Then this total number I want to divide it by the total number of trips, all travel times. So, then what I will get? I will get percentage of trips, total percentage of trips or percentage of total trips happening with 5-minute travel, percentage of total trips happening with 10-minute travel, percentage of total trips happening with 15-minute travel and so on and so forth. Okay. So, that is what we want to get. What we can call that? That we can call trip length frequency distribution, trip length in terms of travel time of the trip. So, we have certain trip length in terms of travel time and the corresponding frequency, percentage of total travel that is happening with that travel time. Now, if I have really taken the values correctly, which actually working or reflecting the real travel, then my observed trip length frequency, that means what is my observed travel with 5-minute, 10-minute, 15-minute, 20-minute, okay, percentage of total travel made with all each of these travel time values, right. As we have observed and as we have got the values from the model, they should exactly match. They should give a very close match. So, what we are doing here, the criteria is to identify the correct travel time factor relationship is the trip length frequency distribution. So, we are comparing these 2 trip length frequency, one as we have obtained from the gravity model output, okay, and as we have obtained from our field observations. Again I am saying what is my x? My x is the travel time or the trip length. What is my y? Percentage of total trips happening with that travel time. Then I have got one blue line, one red line shown here. What they indicate? The one is based on the gravity model, one is based on the observed value. So, the shape and position of simulated means what you have got from the gravity model output as just I have shown in the previous slide, and observed trip length frequency distribution curves should be relatively close visually. Once I plot them, they should appear to me, yes, there is a reasonable match, a reasonable good match with these two curves, and the differences between average trip lengths or average frequency rather, right, the percentage of trips within acceptable limit. Okay. So, two curves basically should match, right. So, here you can see these graphs, one is the blue line which is the estimated and the red line is actually observed. So, you can clearly see for 5-minute travel, whatever my gravity model is saying percentage of trips, it is actually overestimated, very high percentage, nearly 40% trips are happening with that, but in reality only less than 10% is happening. Similarly, for 10-minute travel, again my model overestimated, but on the other hand, for higher travel time or trip length, say for 30-minute, 35-minute, the models are underestimated. Okay. So, now that clearly shows the friction factor values corresponding to different travel times, what I have assumed those values are not correct. So, you have to modify them. How to modify? How we can modify? We can modify based on looking at this graph or looking at the actual values. Say friction factor values are used as a multiplier. So, if my modeled values are higher for any particular travel time, the corresponding percentage share, if it is higher, that means I have used a higher multiplier value as Fij. I need to actually reduce it, right. You have multiplied with some value and you find that total value is percentage is higher. So, that means you have actually used a higher multiplier, higher value of the for the multiplied Fij. If you have got lesser, that means you have used a lesser value, then you should increase it. If you have used, if you find you are overestimating, the model trips are overestimated, then you have used a higher value, you should actually reduce it. So, those adjustments are to be done. How those are to be done? Before you do that, I have shown it here. Let us say that you know the model value and we know also the observed trip lengths. So, you clearly see there is a big difference. Visually also this slide showed you that they are not matching, and here in tables also actual values also show that they are not matching. Somewhere you have overestimated, somewhere we have underestimated. So, we need to modify the friction factor values. How we modify? As I told you, this is the formula. My friction factor value for a given travel time, if it was f, and then the new value should be f dash equal to f into observed percentage divided by as the percentage you got from the gravity model. As I say, if gravity model has overestimated, right, gravity model value is more, that means the Fij value should be reduced, that is what will happen. If the gravity model has underestimated, that means I have used a lesser value, I should use a higher value of Fij. So, accordingly this will give you higher than f value for the f dash, right, or the modified friction factor value. That way let us modify it. So, these are, this slide shows that what is my observed trip, what is my estimated trip from gravity model, and what was the travel time factor used in the first iteration, and then how using this formula modified friction factor equal to friction factor which was used earlier in the last iteration, and by using that what observed gravity model percentage you got and what is your actual observed percentage for that travel time, right. You can compare and then accordingly modify it. So, exactly following that we modified the value of Fij. I have shown you here how the modification is being done. As I said, if my gravity model given me higher value than the observed, then Fij value I have used is higher, I should reduce it. And if my gravity model has given me lesser value than observed, then I should use a higher multiplier. So, my Fij value should increase. Exactly you see it here. Your estimated value in the gravity model is 38% and your travel time actual observed value is 4%. So, you used actually a value of 4. So, the 4 value is very high. So, we need to reduce it. So, what we will do? 4 multiplied by what we actually got observed 4% divided by gravity model says 38%. So, now you should use the value of 0.42. We are shaping up. So, with whatever travel time, whatever is the condition, accordingly the values will be modified. So, now you have a modified value as you have shown. With this you go again for the second iteration. Again you produce 3 tables. First you calculate Fij value for each cell with respect to each I. So, row 1, then all the j values, row 2 all the j values, and then sum it over Aj Fij, then Aj Fij divided by sum over Aj Fij, then again multiply it like Pi into Aj Fij by sum over Aj Fij. So, take the respective productions of each row, multiply it by the corresponding cell value what you have got in table 2, you get the thing. Here again the productions will match automatically because it is a singly constant model. Again you calculate how many trips with 5 minutes, how many trips with 10 minutes and so on, and then what is that percentage of trips considering the total trips, how much percentage of total trip. Now, the model is predicting with the revised Fij value with respect to various travel time. Again you compare, you find in this iteration you are realizing that now you are getting a slightly better fit. It is even much better as compared to what you got in iteration 1, but still it is not matching. Probably you expect even it should match more closely. Go for one more iteration. So, again modify the value of f. So, I have shown here what f we used in the second iteration, and then with those f what percentage of trips with respect to each travel time we got from our gravity model and what percentage of trip is actually observed. Based on that, again I fine tuned the value and then go for iteration 3. Go for iteration 3, calculate it again. Again all the steps are similar, right, and now again you see, you find even now more or less it has matched. So, I stop here my iteration. If you are still not happy, continue. So, finally, it will exactly match. That means, how the distance is acting as a deterrence, the travel time in this case, right, because we have taken it as travel time. So, how the travel time is acting as a deterrence, Fij value is exactly capturing that. So, that the trip length frequency, the frequency of travel with respect to each trip length, as you observe in the reality or in the field and as you are getting from the model are exactly matching. Now, in a bigger network, let us say in a big city you are working. So, the travel time may vary from 5 minutes to maybe 120 minutes, 130, 140 minutes. So, for every 5 minutes you will do or every minute you will do, there will be many, not always the values will be in 5 minute multiple. What I will do in that case? In that case, what is possible? Probably you create several groups, maybe 0 to 5 minutes, 5 to 10 minutes, 10 to 15 minutes, every 5 minutes I am grouping. You can do it every 10 minutes, right. So, like that, create different groups and put all travel together in that group and represented the group with a mid value. Okay. So, suppose I have every 10 minutes I have created a group every for with a difference of 10 minutes, then 0 to 10 minutes represented by a midpoint of 5 minutes, 10 to 20 minutes represented by a midpoint of 15 minutes. Then you consider 5 minutes, 15 minutes, 25 minutes, like that up to maybe whatever is the upper range you consider, and then you actually follow the same thing, take the midpoint. But once you get the curve, now even any intermediate value, right, if I have got 8 minutes, what is my friction factor value? I can get it from the curve, you have established it, right. Now, one more thing is important here, which I have not discussed, I will mention briefly, zone to zone adjustment factor. Okay. See, now we are matching the total 2 minute travel, 5 minute travel, total 10 minute travel, total 15 minute travel, but this total is coming from multiple pairs. Maybe 15 minute travel is happening in 3 different pairs, 3 different Tij values combinedly giving me this total 15 minute travel. I have matched the total 15 minutes travel. I have not matched each and individual cell. Suppose it is coming from 3 cells, collectively this much. Individual 3 cells as obtained from the gravity model. Gravity model also gives me a trip distribution table, and field also I know the each cell value. So, cell to cell may be not matching. The total with 15 minute travel, total 10 minute travel, total 20 minute travel matching, but within 15 or within 20 or within 10 minute travel, multiple cells may be there, those cells are not matching. So, now here you use zone to zone adjustment factor or Sij value, what I used in the initially in the gravity model. So, now you can use some factor to make some gross kind of adjustment and agreement to each and every cell within the total. So, the total is matching, now it is zone to zone socioeconomic adjustment factor you can do to match those. So, what we discussed here? We discussed in details about the BPR calibration procedure. We said that what is the relationship between F and Fij and Tij, then finding out the minimum travel path, then travel time factor relationship, estimation of trip interchange, all the steps we said, and how we can get the new set of value and how finally it should match closely. The observed and the model trip length frequency should match, and that is what is my calibrated values, and if I join all those values, that gives me a curve, right. So, with this I close this lecture. Thank you so much.